Hi, in assignment 6, we will be learning how to name covalent compounds. After that, we will be taking the information that we learned in assignment 5 and assignment 6 and putting them together to write equations that are formed from chemical compound words. We'll also do a lab in this assignment. In the lab, you will be performing 4 different chemical reactions and looking for the signs that you have a chemical reaction that occurs. You need to turn in the observations for each of the chemical reactions and what signs you saw that you did indeed have a chemical reaction occurring. You will also need to turn in the lesson assignment work. You do not need to turn in the practice problems. The practice problems have the answers so that you can check your answers before you do your lesson work. We'll start off by defining a covalent compound. A covalent compound is a compound that consists of two nonmetals. And since they're both going to be nonmetals, neither one of them wants to give up electrons, but they will share electrons. Since there are several different compounds that can be formed, like for instance, we can have one nitrogen and one oxygen, or we could have two nitrogens and four oxygens, we have to use a little different method of naming these compounds. And to do that, we use prefixes. 1 is mono, 2 is di, 3 is tri, 4 is tetra, 5 is penta, 6 is hexa, 7 is septa, 8 is octa, 9 is nona, and 10 is deca. Now, the rules for writing these, you don't use mono for the first element. So if you only have one of the first element, like in NO right here, you wouldn't say mononitrogen monoxide. It would be simply nitrogen monoxide. Also, when you have oxygen or anything that's going to produce a double vowel, you're going to drop the vowel that's with the prefix. So that's the A's and the O's. Now, for the second one, we do have more than one of the first element, and so we would use a prefix. There's two nitrogens, so this would be dinitrogen. And there's four oxygens, so it would be dinitrogen tetroxide. You're going to drop that A. And you're going to change the ending to IDE, just like we did with the ionic compounds. Now, I want to let you notice something really quickly. Septa, octa, nona, and deca. Septa means 7, octa means 8, nona means 9, and deca means 10. But September is the 9th month of the year, October the 10th, November the 11th, and December is the 12th month of the year. The reason this happened with the months is because July and August were added in there later on by Caesar, and it moved all of the numbering of the months. So 7 does mean septa, even though September is the 9th month of the year. Here are a few practice problems that we're going to look at. The first one, there's one carbon and two oxygens. So this would be carbon and Prefix for 2 is di, so it would be carbon dioxide. Here we have 1 nitrogen, 1 oxygen, so it would be nitrogen monoxide. Remember, you're only going to use the prefix mono when the second element only has 1. In the third one, we have 2 nitrogens and 3 oxygens. So nitrogen would be dinitrogen for 2 nitrogens. And oxygen, there's 3, so it would be dinitrogen trioxide. Stop the video here and work these 5 problems, and then come back and check your answers with me. Number 1 is NH3. So 1 nitrogen and 3 hydrogens would make it nitrogen trihydride. Now there's a few compounds that also have common names, like for instance H2O would be dihydrogen monoxide, but it has a common name of water. Same thing with NH3. NH3's common name is ammonia. Number 2, PCl4. 1 phosphorus, 4 chlorines. So this would be phosphorus tetrachloride. Number 3, SO2. 1 sulfur, 2 oxygens. So this would be sulfur dioxide. Number 4, SO3. 1 sulfur, 3 oxygens. That would be sulfur trioxide. And number 5, P2O5, would become diphosphorus pentoxide. Remember, drop that vowel on the prefix if you have oxygen. Now, when we write formulas from the names, we're not going to cross over or anything. We're not going to have to look at the periodic table. We're simply going to write the element and then put its prefix as the subscript. So sulfur hexafluoride, there's no prefix on sulfur. And so there's 1 sulfur. Then you have fluorine, and hexa means 6. So this compound would be SF6. Carbon tetrachloride, 1 carbon, and tetra is 4, so there would be 4 chlorines, so it would be CCl4. Dinitrogen tetroxide would end up being N2O4. Do not simplify covalent compounds. You would simplify an ionic compound, but not a covalent compound. Stop the video now, work these practice problems, and then come back to the video to check your answers with me. Number 1, oxygen difluoride. Oxygen has 1, so there's no subscript. Fluorine has 2 because the prefix is di, so the compound would be OF2. Number 2, carbon disulfide. Carbon has no prefix, so there's 1 of them, so I'm not going to put a subscript. And there's 2 sulfurs, so it would be CS2. Carbon tetrachloride, no prefix for carbon, so that means there's 1, so there's no subscript. Tetra means 4, and so there would be 4 chlorines, so this compound would be CCl4. Tetraphosphorus hexoxide. Tetra with phosphorus means that there's 4 phosphorus, so 4 would be the subscript for phosphorus. Hexoxide, hexa is 6, And so oxygen, so it would be P4O6. Number 5, chlorine trifluoride. Chlorine has no prefix, so there's one of them. Fluorine has a prefix of tri, so there's 3. So that means chlorine trifluoride would be ClF3. Now we're going to start looking at some chemical reactions. You can stop the video here at this point and conduct the lab if you'd like, or you can wait until after you finish the video. But these are the main signs that you would have a chemical reaction that occurs. And the first sign is that gas bubbles would be produced. The second sign is that there's a change in temperature. If it gets colder, then we have an endothermic. Endo means it's taking in, and it's taking in heat. And so that would be an endothermic reaction. Exo means exiting, and so an exothermic reaction is one that's going to get warmer. Another sign of a chemical reaction occurring is a change in color. And then the last sign would be a precipitate being formed. Now, there's not really a good reaction that I could give you with chemicals that you can find in your house. So we're going to watch a little video real quick of a precipitate that's being formed.
In the double displacement reaction of lead nitrate and potassium iodide, we have a colorless solution of lead nitrate. We'll add a colorless solution of potassium iodide. As the potassium iodide reacts with the lead nitrate, we get the formation of a bright yellow solid, which is lead iodide.
A precipitate, by definition, is simply an insoluble product. So it's basically something that will not dissolve in water. In that last example, where the bright yellow precipitate was formed, we had lead 2 nitrate and potassium iodide. These are both what we consider aqueous. Aqueous means simply that it's able to dissolve in water. And what we produce is lead iodide, which is our precipitate. And so since it's insoluble, it's going to stay as a solid, and potassium nitrate. And potassium nitrate is also aqueous. And then I'm just going to balance this, even though we haven't really balanced equations yet. But I'm going to balance this one. And so this would be the reaction. This is the bright yellow precipitate that we saw. When we write a chemical reaction or chemical reaction from formula, we're going to have the reactants on the left side of the arrow and the products on the right side of the arrow. The arrow we read as the word yields. So we would say reactants yield products. What happens in a chemical reaction is the bonds between the reactants are going to break apart, and then they're going to form new products. Now, the symbols that I put in the last section tells you S for solid, L is a liquid. A liquid would either be water, mercury, or bromine. Those are the only 3 true liquids that we would encounter in this course. G is for gas, and aqueous simply means that the substance is mixed with water. So if I'm looking, also you need to look at for diatomics. Diatomic elements are just elements that are so reactive that they're never ever going to be by themselves in a chemical equation. And so we'll always put a subscript of 2 behind them. An easy way to remember the diatomics is hydrogen and the magic 7. There's 7 diatomic elements. Hydrogen is over here on the periodic table by itself. And then if I come to the other side of the periodic table, I'm going to get nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. So hydrogen's over here by itself. The other diatomics actually make a 7, the shape of a 7 on the periodic table. Now, when we write compounds, we're going to write the compounds just like we did before. If I have sodium chloride, sodium has a +1 charge, chlorine has a -1 charge, and so when I would cross it over and write the compound, it would be NaCl. Then potassium iodide, potassium has a +1 charge, iodine has a -1 charge, and so this would be potassium be Ki. Then I'm going to write my yields arrow, and it's going to yield. The bonds between these compounds are going to break, and they're going to reform into sodium iodide. Sodium has a +1 charge, iodine is -1, so it's going to be NaI. plus potassium is +1, chlorine is -1, and so it would be plus KCl. Go ahead and do the next one, and then come back to the video and check your answer. The second reaction says lead 2 nitrate plus sodium bromide yields lead 2 bromide plus sodium nitrate. Lead, the Roman numeral 2 tells us that lead has a +2 charge, and nitrate is a polyatomic with -1 charge. So it would be Pb, open parentheses, NO3, close parentheses, 2, plus sodium bromide. Sodium has a +1 charge, bromine has a -1 charge, and so it would be NaBr. Lead 2 bromide. Lead has a +2 charge. We get that from the Roman numeral 2. Bromine has a -1, so this would be PbBr2. Sodium nitrate. Sodium's +1, nitrate is -1. Cross them over and the compound would be NaNO3. Now go ahead and try the next one and then come back to the video and check your answer. Sodium plus chlorine is going to yield sodium chloride. Remember, when you write a single element, you have to ask yourself, is it a diatomic? So sodium is not a diatomic, so I don't put any subscript behind it. Plus chlorine. Chlorine is a diatomic, so I'm going to put a 2 behind the chlorine. And it's going to yield sodium chloride. Sodium has a +1 charge. Chlorine has a -1 charge. And so the compound would be NaCl. Now go ahead and try the next one. And it gives you the state of matter. So right behind each of the compounds or elements, go ahead and put the state of matter. The last one tells us that liquid carbon disulfide reacts with oxygen gas to produce carbon dioxide gas and sulfur dioxide gas. These are all covalent compounds, and so we're using the prefixes to help us name them. Carbon disulfide would be CS2, and we're told that it's a liquid, so the state of matter would be L. Plus oxygen gas. Oxygen is a diatomic, so we'd have to put a 2 behind it, and it's going to be a gas as its state of matter. And that's going to yield carbon dioxide, CO2, which is a gas, and sulfur dioxide, SO2, which is also a gas. Now go ahead and work the practice problems and the lesson problems and turn them in to be graded. And I'll see you in assignment 7.